coming to the routing protocols on the IGP, Interior Gateway Protocol. So there comes a distance vector protocol and link state and hybrid, right? What is hybrid routing protocol? Okay, first we'll go with distance vector. So hope you can see my screen, right? Okay. So distance vector. So with the distance vector, what exactly distance vector routing protocol uses is they uses the distance to reach another network. It's not another router, it is another network. Network in the sense of the IP range. Whatever we are going to define in the routing table.
Can you
so that,
type that down?
sorry?
Can you type it?
Yeah. So first is distance vector protocol. Distance vector. Okay. So here, this routing protocols are going to use distance. Okay, distance as a metric to reach the network. Okay, so distance is nothing but distance as a metric. So metric, yesterday we were discussing about metric, right? So what is metric? So metric is nothing but a unit. A metric is nothing but a unit to measure the routing protocols trustworthiness. Oh, sorry, not trustworthiness. To calculate the best part. Trustworthiness is for the administrative distance. So metric is a unit to measure routing protocols best path calculation. So how a routing protocol is...
You're saying so fastly, I'm unable to write.
Sorry?
Or else can you type? Like
Okay.
I'm unable to write. You're telling so fastly.
So what is metric?
Yeah, metric is one.
Metric is a unit to measure. Okay, it's a unit to measure or calculate the best path to reach the destination. Okay, that is metric. So here distance vector uses distance as metric. Okay, so distance is nothing but the distance to reach the network, the destination network. Okay, like how much distance is? So like how many hops are between the routers to reach the destination. So example, RIP uses metric as a hop, right? So it is calculating based on the hop. So how many hop in the sense how many routers it is going to jump to reach its network. Okay, so maximum it's like some 15, I guess. 15 is the maximum count. After 15, the routers is not going to like check for its destination. It can reach maximum 15 hops only for distance vector. So there's a limitation. Okay. And vector. What is vector? Here, vector is nothing but the interface. Okay, vector is nothing but the interface or the direction to reach the network. direction to reach the network, which interface I need to exit, or which direction the packets needs to be routed. So that is the vector. So together, distance vector uses the metric as distance, as such as number of hop count. Okay, and vector is nothing but the next router's IP address used to reach the destination. So direction, either next router IP, the next hop IP, or the exit interface means the direction to reach the network. This is how distance vector routing protocol works. So when a router receives the routing information, so here what's happening is the router, each router is going to advertise its own networks alone. So it's going to, it's going to receive, it's going to advertise, and it's going to receive the other routers, the directly connected neighbors router information as well. Okay. So it's going to advertise its network, and it is also going to receive the other routers advertised network information as well. Okay. So, based on this information being shared between the routers, it's going to store all those information in the local routing database. So whenever it receives any router information, it's going to save it in the local routing database. Okay, and this is like works based on the Bellford algorithm. Bellman algorithm. Bellman Ford algorithm. Okay, so distance vector routing protocol works based on this algorithm. So this algorithm works in such a way that it advertises and receives all the routing information, and all the routing information are being stored in the local routing database. So, and also any dynamic routing protocol for this matter is going to check for the path which is best and the loop-free path. Okay, for any routing algorithm, it is going to check the best path, and it's going to be, it's also going to be a loop-free path. There should not be any loop in the network. So, any data being sent on one interface, the same data should not be received on the same interface. It has to reach the destination router only. It should not reach the same old router where it sends. So that is a loop. So it's not going to loop the network. Okay, through this routing, it's not going to loop because it is dynamic, right? We are not going to define any next hop IP address. Manually, we are not going to configure anything. Though end-to-end routers are connected, directly connected to each network, we are not going to define any next hop IP addresses in the router. We are going to route the network, whatever network we are using inside our LAN. We might use 3 VLANs. So that means 3/24 network, 192.168.1.1, 192.168.2.network, 192.168.3. So we are using 3 networks. So we have to advertise these 3 networks through dynamic protocol. That's it. We don't know who is the neighbor IP. Not bothered. We don't know what is the directly connected next hop IP, that is the neighbor's IP interface. No, we don't know. We are least bothered about that as well. We are just going to advertise, but we need to make sure the other router, the neighbor router, or whichever, whatever network we are forming with the routers, all the routers should run with the same routing protocol. So all the routers in a network, should run the same routing protocol. So only then you will form a network, only then routing will happen. Okay, only then routing will happen, and packets will be exchanged between each router. Okay, updates can be shared between the each network or routers. That is possible only if the routers in your network runs with the same routing protocol. If I'm using RIP, yes, RIP on all the routers. Say I have 10 routers in my network. All the 10 are belongs to different geographical location. All the 10 should run with RIP or OSPF or EIGRP. Okay. So yes, so that is on the routing protocol, how we have to configure. But routers running on distance vector protocol, it's going to advertise, like I said, it's going to advertise the routing information to their neighbors. Okay, from their own networks only. Whatever networks they have, they are going to advertise it. Okay. And therefore, they are going to receive the other routers information as well, routing information as well. So these exchange are going to happen in a periodic manner. What's happened is, so every time when the router is going to give an update to the neighbor or getting an update from the neighbor, every time the entire information about the routing is getting updated in the local routing database. So full information, say I have 5 networks. Additionally, a 6th network I'm adding. When the router is when the routing information are being exchanged between the routers, all the 6 informations are being exchanged again. Then I'm adding a 7th network range. Okay. Then what's happening is, not only the specific 7th network is getting advertised, entire 7 networks is getting advertised again and again. So every time the whole routing information are being shared by each other. Therefore, what's happening is, due to which like the routing database, the exchange packets are huge. But there is one advantage of the distance vector is it uses very less CPU memory. Okay, it's not going to process anything much. So it's very minimal. It's going to consume only very less CPU and memory. And the load on the routers is also less. That is the only advantage. But when it comes to exchanging the routing information, it is going to be huge. Every time it's going to repeat the same process again and again. Okay, that is distance vector. Okay, next is link state. Link state routing protocol. So in link state routing protocol, like the name itself, link state, yes, the metric is nothing but the status of the link. What is this link state? So status of the link, or the status of the link is getting calculated with the help of cost. Okay, so here the metric is calculated by cost of the link. Okay, so if I'm having a leased line connection and a serial connection between 2 routers, then leased line connection is preferred than the serial due to bandwidth, because leased line can have more bandwidth, whereas serial will be restricted with 1.5 meg of bandwidth. So based on the link state, the metric is calculated. So which metric is nothing but the best path is calculated. Okay, on the link state. So in the link state, actually, it's going to exchange information about the each links, a directly connected link to the routers or to every router in the network. Okay, so what are the links that are getting directly connected? So each router is going to share information about their links as well. Apart from the routing of the networks, IP ranges they have, they are going to share the link state as well, about the link state of the directly connected network, or like what to say, each of the links interfaces, what are the link connected? Is it serial link or VLAN link or a point-to-point link? Anything for that matter, that is also being captured. Okay. So these link state routing protocols are majorly used in an enterprise level, on high-end level or service provider end only they use. So basically, say if we take OSPF is one of the link state protocol. So OSPF, what it is going to use, it is going to advertise its information with the help of LSA packets. LSA is nothing but we will go through in another time when we cover OSPF also, right? Or link state advertisement. This is LSA packets. So this is LSA. Link state advertisements are going to happen. And what it is going to advertise is link state packets. Okay. Okay, so the advertisement process, we call it as link state, LSA. LSA is going to happen between the routers. And that LSA advertisement, what is actually contained is the link state packet for each advertisement. Okay, it is advertising, okay, so and so networks are behind this router. And these are the link states as well. So that is called a link state packet. So as a router receives an advertisement from a neighbor, again, it shows in the local database, like how distance vector we saw, it's going to store in the local routing database. It is also going to get stored in the local routing database. But here we call that database as LSDB. We are going to call here as LSDB, link state data. Okay. So that routing information about the local database, we call it as link state database. And this advertisement about the link information about each neighbor, directly connected neighbors, exactly what they receive is there maintained in this database. Okay, so this information are being just flooded throughout the network between all the routers, just originally from the like it is whichever router is advertising, it's going to send it to all the routers in the network, right? So what it is going to do, it is going to allow all the routers in the network to get a synchronized and an identical map of the network. So when it is getting flooded, so this link state database contains what? Nothing but the local routing information about the link state, right? About the link state packets, about the network information. These are going to get flooded throughout the network, throughout the routers in your network, wherein all OSPF is running. Okay. And by flooding this information, this is going to form an identical map of network. So it's kind of a topology which is going to form by itself to just let know, okay, this router, this link is up or this link is down. Okay, if this link is down, then what would be the alternative path it should take? So it is going to calculate in that way by forming a network map. Okay. And here the protocol what we use for link state routing is called as, so that means it is going to calculate the best path and a loop-free path, right? So due to so it's going to form a complete map of the network. So what is happening is actually the link state protocol usually require more CPU and memory than the distance vector to run and maintain a network map for all the routers. So it's for that reason it obviously consumes more CPU and memory. But it is very less to find the best path. But it is the best to find the best path. Like not like what to say, distance vector where there's a limitation of maximum 15 hop count, right? But here there is no limitations like that. It can contain any number of routers in the network. Still, it can be able to find a loop-free and best path. Okay. And so this is about link state. Just an overview about link state. In detail, we have many link state advertisement packets, database, LSA1, LSA2, and all. There are many things that comes when you go in depth of OSPF topic that will be explained on that chapter. Okay. Next protocol is enhanced, that is we call it as hybrid routing protocol, right?
Can you give the definition of
Sorry?
can you give the definition of this
Definition of
Dijkstra's
what?
shortest path algorithm?
Any definition? Here?
For the algorithm.
Okay. Hybrid routing protocol.
No, talking about the shortest path algorithm.
Sorry, your voice is so low. You want to get clarity on anything?
Can you hear me now?
Yeah, I can hear you, but it was low at that time. Tell me, you want anything to be clarified?
I want like exactly like any definition about Dijkstra's shortest path algorithm.
Like how distance vector, the combination of distance and direction. This is there's nothing, there's no definition. So this works based on the link state. There's no specific so what it does actually is, so every router that runs this algorithm is going to find the shortest path by calculating the link state. That is shortest path is getting calculated from the link state.
That means cost. Like link statements cost only, right?
Sorry?
Link statements cost only, right?
Cost, based on the cost. The metric is cost.
Okay,
Cost
okay.
of the link. Yeah. Now hybrid routing protocol. So hybrid routing protocol, or we can also call it as enhanced distance vector. Enhanced distance vector. Once again. Okay. So hybrid routing protocol, we also call it as enhanced distance vector. Okay, so that is nothing but a fusion of both distance vector and link state. So together is called as enhanced distance vector, or we can also call it as a dual diffusion algorithm, anything for that matter. Okay, dual routing protocol. Okay, that is it, since it's a combination of both. So what it is going to calculate is, so this is going to calculate the shortest path within the network with some certain with certain metric values that is used in this algorithm. So one is it's going to use bandwidth. Check the bandwidth of the link, delay, reliability, load, okay, and MTU, maximum transmission unit, MTU size for the path calculation. So these are the metrics used to define the shortest path in this hybrid routing protocol. So basically EIGRP will come here. Okay, so it's going to calculate these things. So what is the bandwidth of the link? What is the delay of the link? If the link is reliable, okay, load and MTU size. So if you hit the show interface command, if you check the show interface command in any of the active interfaces, by default, you will get the link states, the value for these parameters of the link. Okay, so maximum for all the link, it will be like default, it will be like same only. But if there's any link issue, if there's any packet drops, or if there can be a lower bandwidth of the link. So based on that, it calculates the best part. So mostly delay, reliability, load and all will be same on the MTU size. Only the bandwidth part only will differ. It is variant. It can vary based on the type of the cable or bandwidth we use. But apart from this, these are all the default values only. So based on this only, the metric is being calculated. So this protocol is going to offer a rapid convergence time for any changes in the network. So if there is any change, if there is any link failed, so immediately it's going to update all the other routers in the network, and all the other router is going to update its routing database. So all the convergence time is quick in this algorithm, sorry, in this hybrid routing protocol category. And again, it is going to send updates only when there is a change in the network, right? But earlier, what we saw in the distance vector, periodically it is going to update, advertise its own information to all the routers in the network. And it is also going to receive, because the other router is also has to send a update, right? So it is also going to receive all the routers information periodical manner. So every time it's going to keep receiving updates, sending update only. But in EIGRP, what is going to happen is it's going to send update only when there is a change in the network. If there is a link change, okay, I'm using a bandwidth of 2 meg. I'm upgrading the link to 5 meg or 6 meg. Yes, there's a link change happened for a particular router connection. Yes, then it will get updated. Or if some router there's a link that has gone down, then only at that time the routing database is getting updated. So at that time only the advertisements is happening about the network. You know, this network via this interface you cannot reach it. So you should find an alternative path. So it is just sending information that this network is down. So what are the other routers? Say I have 10 routers. One router's LAN interface is down. So I cannot reach the VLANs on that router, behind that router. So what the remaining routers is going to see is, okay, to reach this network, this is not the path. It should find another alternative path. So again, it is going to calculate the best path based on the bandwidth and update its routing table. So this is how it's getting updated only when there is a change in the network. And that convergence is also very fast, rapid convergence. And also it is not going to send full routing table updates in the periodic fashion. No, like how distance vector is going to do. No, it's not going to be a periodic full update. First time whenever a network a router comes into a network using EIGRP, it's going to advertise its full information. Whatever networks it has, whatever link it is using, it's going to update its full information only for the first time. Next time onwards, only when there is a change, it's going to update only the changed information. Okay, not the full information. Whatever changes are there in the routing information or on the link, it is going to update only that information. So that's why it's not going to send full routing table updates as well. So in that way, the packets that are being exchanged between the advertisements, during the advertisements, whenever there's an exchange of packets between our routers is going to happen, that is going to be of very minimum size only. Okay, so that is the advantage. And how it is like sending updates between the routers is by sending a hello packet first, initially. So this hello packet information is being sent with the distance vector protocol as well as link state as well. Link state is also in order to form a neighborship, in order to initiate, okay, so I am so-and-so router, I am having this many networks. That is that in order to initiate that information, it's being sent through an hello packet. Says hello, I'm here. The other router also says, hello, I'm here. These are my information. So on distance vector and as well as on the link state, it's going to exchange with the hello packets only. Okay. And load balancing can be done here in the enhanced distance vector protocol. Load balancing of the traffic with equal and unequal cost path is done. Load balancing is done. Load balancing of traffic across equal or unequal cost path. So for one link, I am having 100 meg bandwidth, and the other link I'm having 50 meg. Since still I can load balance my traffic between both the links. So the cost path of both the links need not be same. It can be different, but still I can load balance or send my traffic equally, split and send my traffic equally to two of the links, because I need not purchase one high bandwidth link. What if that is going to fail? I should have an alternative link, right? So I can buy another link, but it can be of less cost or less bandwidth. Even though if I'm going to purchase a link with less bandwidth, then still I can share the network traffic on both the links. That is also possible in the enhanced distance vector. So by default, it's going to advertise the delay, bandwidth, and all this. These are the information it's going to advertise in order to calculate the shortest path. So path vector actually, this algorithm is used by the BGP protocol. It's a kind of a similar to distance vector only, but there's a difference. Instead of looking into distance only, it calculates with different various attributes. Here we call it as attributes to calculate the shortest path. So when we are mentioning as traffic across equal or unequal cost path, okay, I have a router 1 and I have a router 2. Okay. So these two routers have two links connecting these two routers, okay, in order to have a redundant path. Okay, so I have two links, primary and secondary link. The primary's bandwidth is say 10 meg. Okay, 10 meg bandwidth. And secondary link is going to be idle only. correct? So primary only I'm going to send traffic. Secondary link is going to be idle. Why? Because it will be used only in the when the primary link fails. Only in that scenario we need to trigger, or the secondary link will be up. So at that time, I have to purchase two links. One is 10 meg link, and again another secondary link with also 10 meg. So that is going to be a expensive only for me, right? When I'm designing a network, that will be expensive only. So in that case, what I will do, I'll purchase a 5 meg link for the secondary part. Anyways, the secondary link is not going to be active all the time. It is going to be idle only. Whenever there's a link failure on the primary, the secondary link will be activated. So since anyways the secondary link is going to be idle only, then why I need to spend money and purchase 10 meg link? Instead, I'll reduce the bandwidth to 5 meg, and so that I pay half of the cost only, half of the price only. So that's how the network engineer will plan, or the architect will plan. Okay, I purchased a file, but based on this enhanced distance vector protocol, it is also calculating the bandwidth, delay, reliability, load of the link to calculate the shortest path. So anyways, based on the higher bandwidth only, it is going to send the traffic. So that is considered to be the most preferred link, right? My link with lower bandwidth is least preferred only. Okay, with that point, in order to have my network with full redundancy, I've purchased two links. That is my requirement. Anyways, I have to spend extra money. I have configured another secondary link. But instead of keeping the secondary link idle, I'm going to load balance the network traffic. Anyways, I have secondary link idle. Why can't I send some traffic on the secondary link? Okay, if at all, if my network, my users are sending many traffic, huge traffic, I can at that time, when my primary link is 80% or 90% utilized, I can send few of the network traffic to the secondary link. So at that time, I'm going to do a load balancing. I'm going to do a load balancing in my network. So for that, both the links need not be in the same bandwidth. Same bandwidth means same cost. Okay, it can be unequal as well. One can run in 10 meg, the other can be at 5 meg. So that means equal or unequal cost path. Both can be 10 meg or both can be like unequal, 10 and 5 meg, or 5 or 2 meg, anything for them. So load balancing is possible through EIGRP protocol, even though if I have an equal or unequal cost path. That is the main
So
particular.
what happens if the secondary link also fails?
Sorry?
What happens if the secondary link also fails?
What are the?
What happens if the secondary link also fails?
Then that the network is down. We cannot do anything. So to some extent, we can have primary, secondary links. So if the primary link is down, the secondary is the backup. Yes, it will be activated. It can be used, but by the time we need to make sure to bring the primary link is up. Okay, so we have some buffer time to work on the primary link to check what is the issue in the time and bring it up. That is the only thing we can do.
Okay, thank you.
Okay, yeah.